welcome to the class. So in the previous videos, we have discussed about aldehydes, ketones, and carboxylic acids. So here, without wasting much of our time, let us start with the multiple choice questions. Let us see what type of questions we are going to encounter. Here we are going to encounter the questions based on IUPAC nomenclature of aldehydes, ketones, carboxylic acids, derivatives of carboxylic acids. We have already seen which are those derivatives: acid chlorides, anhydrides, esters, amides, and all. Okay. Apart from that, we are going to see the methods of preparations as well as the chemical reaction compounds. Okay. So let us take the first question. Here we have the first question. The question says, the IUPAC name of the given compound. You can see the compound given there. They have asked you to write the IUPAC name. Yes. So the compound is CH3, C double bond O, and CH3. Very simple question. So this is nothing but a ketone with 3 carbon atoms. It is prop, single bonds. Always the single bonds have to be seen between the carbon atoms. And for ketone, it is ONE, propanone. Yes. So propanone is the correct answer. So it is on second carbon atom. So it is 2-propanone. Yes. Acetone, you may feel it correct, but acetone, what you can see here, acetone is not the IUPAC name. It is the common, or you can say the tribal name. Yes, you should be knowing some of the tribal names also. We have 2 systems of nomenclature. One is the common name and another one is the tribal name. Yes, sorry, common or tribal name and another one is the IUPAC name. They have asked us IUPAC name. So it is 2-propanone. Sometimes the number 2, the locant, the number can be, you need not write it, because propanone is a compound with 3 carbon atoms and I cannot have 1 propanone, right? It is always 2-propanone. Cannot have 1 propanone because see, remember this. Yes, I'm not speaking about carbonyl group. I'm speaking about ketonic functional group. Ketonic functional group is a non-terminal functional group. Yes, when we are solving questions, we should come across all these things. Non-terminal functional group. That means its position is never at the end. Its position is never 1. It is always in the middle. And with 3 carbon atoms, we can express it to be in the middle, second carbon itself. So it is always 2-propanone. Okay. Even the next compound, the IUPAC name of CCl3CHO. CCl3CHO. So let us break it out. CHO is the functional group, and on this carbon there are 3 chlorine atoms. Again, so numbering always starts with the functional group. So it is 2 carbon atoms. So, and these are the substituents. So, okay, let me write it: 2, 2, 2. Trichloro. 2 carbon atoms. 2 carbon atoms. Phenol, correct? Yes. 2, 2, 2. Trichloroethanol. So this is the correct answer. That is not 1, 1, because functional group gets the locant 1, and you need not mention the locant of the functional group, because CHO is a terminal functional group. Not only CHO as well as COOH, aldehydic functional group, as well as carboxylic functional group. They have they are called terminal functional groups. Their position is always at the terminal position. That means whenever you are numbering, you will start from the carbon atom of aldehydic or carboxylic group only. Yes, so its position is always 1 and need not be mentioned. Right? So the correct option is, it is 2, 2, 2 trichloroethanol. Okay, moving to the next question. So that CCl3CHO, it is having a common name also. It is called chloral. It is commonly called chloral. What it is commonly called? It is called chloral. Okay. Moving to the third question. The location on the carbon atoms next to the carbonyl group indicated as next to the carbon atom. See, the locations of the substituents, they are indicated by Greek letters. Yes, you already know this. They are indicated by Greek letters. That is, the Greek letters are alpha, alpha prime, beta, beta prime. Means if this is the functional group, okay, this carbon becomes alpha. If the carbon is on the opposite side, like for example, if you take CH, OH, so if this becomes alpha, this becomes alpha prime, and there's one more carbon, this becomes beta, this becomes if there's a carbon prime. Yes, these are nothing but the Greek letters. So they are indicated by the Greek letters, and so on, beginning with the carbon atoms next to the carbonyl group. So it is indicated as alpha prime. Yeah. So the question what they have asked. So location of the substituent on the carbon atom next to the carbonyl group. So if this is the carbonyl group, so let me take ketonic example. If this is the carbonyl group, this position is alpha, this position is alpha prime. So the correct option is option B. This option B. Moving to the next question. When the aldehyde group is attached to a ring, the suffix dash is added after the full name of the cycloalkane. When aldehyde group is attached to a ring, they are saying. Okay. So let me say, they have not said benzene ring, they have just said a ring. So if I have like this, 1, 2, 3, 4, and 5 carbon. Yeah. So this is nothing but whenever you have a ring structure, we use the prefix cyclo. Yeah. And depending upon the chain, since it is a single bonded chain, I call it as a cycloalkane, right? We call it a cycloalkane. But what they have said, when aldehyde group is attached to the ring, yes, when aldehyde group is attached to the ring, what suffix we use? So if this ring is attached with an aldehyde group, then what is the suffix used? We use the suffix carbaldehyde. We use the suffix carbaldehyde. It is added after the full name of the cycloalkane. After the full name. So like for example, this is a 5-membered ring. I call it as cyclopentane. I call it as cyclopentane. And if you are attaching a CHO group, then I write it as cyclopentane carbaldehyde. Cyclopentane carbaldehyde. Yeah. So this is what how we do the nomenclature, IUPAC nomenclature of the cyclic compounds. So which is the correct option? The correct option is carbaldehyde. Not only for carbaldehyde, even for carboxylic groups also. Even for a carboxylic group, we use carboxylic acid as the suffix. We use carboxylic acid as the suffix. Moving to the 5th question. Alkyl phenyl ketones are named by adding acyl group as a prefix to. Alkyl phenyl ketones are usually named by adding acyl group as a prefix to which of these following? Now, see, let us take an example. Alkyl phenyl ketones. See, when phenyl term comes, we are talking about what? We are talking about a benzene ring, right? Phenyl. Phenyl is the term used for benzene. Yeah? So they are saying alkyl phenyl ketone. So ketone is there and there is an alkyl group. So what they are said, they are adding, they are named by adding, this is the acyl group, correct? Our CO group is nothing but acyl group. So they are named by adding the acyl group as a prefix to what? So this is S, you can call it as acyl, students, or you can call it as acetyl. Acyl or acetyl, yes? Or this group particularly, we call it as acetyl, yes? What is this termed as? Yes, it is nothing but phenol. When benzene ring is attached to C double bond O, we use the term phenol. Therefore, simple example you have, the simplest aromatic ketone is C double bond O, CH3. You call it as acetophenone, correct? We call it as acetophenone. Okay, so acetophenone. So the correct option is option C. It is phenol. Okay, fine. Moving to the next question. 6th question. Which one of the following carbonyl compounds is most polar? Yes. So how do we decide the polarity? It is nothing but the lowest, where there is lowest electron density on carbonyl carbon. There is carbonyl carbon and carbonyl oxygen. Yes, where the lowest electron density is there. Because what happens here is, since oxygen is having lone pair, whenever the bond breaks, this will attract the electrons and oxygen becomes slightly negative and carbon becomes slightly positive. So where the lowest electron density is there for carbon, that becomes most polar. Yes, lowest electron. It should go on decreasing. Electron density should become more and more less. So where it is less, let us see the examples. This is electron releasing group. So it will release the electrons. Okay, this is going to release. This will also release the electrons. This is also going to release the electrons. But hydrogen does not, neither is electron releasing group nor it is electron withdrawing group. Neither electron releasing nor electron. But this group is electron releasing group. So it is going to release the electrons. So electron density on carbon becomes slightly more. But if you look at this example, what is this example? It is methanol, or you can call it as formaldehyde. Yeah, formaldehyde. Formaldehyde is having hydrogen attached to carbonyl carbon, both hydrogens. Hydrogens are neither electron releasing groups nor electron withdrawing groups. So electron density remains the same on the carbon. So this becomes most polar. Yes. So HCHO, formaldehyde, methanol will be most polar. Why it will be most polar? It will be most polar because lowest or electron density on the carbonyl carbon. Yes, lowest electron density on the carbonyl carbon. Fine. So if you want to check out the order also, first comes option D, then comes option C, then comes option B, then comes option A. Right? Okay. So the most polar compound will be formaldehyde. Moving to the 7th question. CH3COCl is subjected for reduction. 2H stands for reduction in presence of palladium poison with barium sulfate. What is this reaction, students? We have studied this. This is a typical reaction wherein we have seen the reaction where it is for preparation of aldehyde only. It is for preparation of aldehyde only, right? And we have seen two reactions for preparation of aldehyde. For preparation of aldehyde. Yes, one is a Rosenmund's reduction and the other one is a Stephens reduction, right? So Rosenmund's reduction says that when acid chloride is subjected for reduction, either I can use or I can use hydrogen in presence of Lindlar's catalyst, palladium poison with barium sulfate. Barium sulfate acts as a catalyst poison, which reduces the efficiency of catalyst palladium. So what do we get? What do we get? So what do we get here? Cl comes out with hydrogen and one hydrogen gets substituted here. So I get CH3, C double bond O, and this is what is shown. It Cl comes out. What is this reaction name? It is nothing but Rosenmund's reduction. Rosenmund's reduction. This reaction is for preparation of aldehydes only. This reaction is for preparation of aldehydes only. Okay, Rosenmund's reaction. Fine. Moving to the next question. Ethyne on reaction with water in presence of HgSO4 and sulfuric acid, mercuric sulfate and sulfuric acid. Ethyne. What is ethyne, students? Ethyne is acetylene. Ethyne is what? Acetylene. Triple bond CH. On reaction with water. On reaction with water in presence of mercuric sulfate and H2SO4 sulfuric acid. What do we expect? We expect, yes, what happens there? We get CH3, CH3. This is one of the method of preparation of aldehydes from unsaturated compounds, alkenes, from alkenes, yes. So we get aldehyde with the same number of carbon atoms. So I call it as corresponding carbon atoms. 2 carbon atoms alkyne, I'm getting 2 carbon atoms aldehyde. What is the name of this compound? It is called ethanol. Yeah, it is called ethanol. Let us see any option. No. But what is the common name of this compound? It is acetaldehyde. The common name of the compound is acetaldehyde, and yes, we have this option, that is acetaldehyde, right? So you should be knowing, so not only the IUPAC nomenclature, there are some very commonly used common names. There are some very commonly used common names. Those common names should be known to your students. Okay. Then benzal, next, moving to the next question. Hope you are following with all the questions. The next question is, benzaldehyde can be prepared from benzene by passing vapors of dash and dash in its solution in presence of a catalyst mixture of aluminium chloride and cuprous chloride. The reaction is known as. So the question is quite very clear. Benzaldehyde can be prepared from by passing. Yes, they have said benzaldehyde can be prepared from benzene by passing vapors of carbon monoxide, vapors. So benzaldehyde, let us see, can be prepared from benzene. So I have benzene. So here I have benzene. And they are saying that benzaldehyde can be prepared from it. Yes, benzaldehyde can be prepared from this. So benzaldehyde, these are this compound. What they are saying is, by passing vapors of dash and dash in its solution in the presence of a mixture of aluminium chloride, AlCl3, and cuprous chloride, CuCl. Yes. So which vapors are you going to pass? And this reaction we have already seen. It is nothing but you're passing the vapors of carbon monoxide and HCl. Yes. So you're passing the vapors of carbon monoxide and HCl in its solution in the presence of AlCl3 and cuprous chloride. And the reaction is known as what? It is known as Gattermann-Koch reaction. It is known as Gattermann-Koch reaction. Okay. So Gattermann-Koch reaction. Fine. So you should be knowing all the named reactions of this, from which we can prepare only aldehydes, the reactions from which we can prepare only ketones, and the general reactions by which we can prepare both aldehydes and ketones. Okay, moving to the next question. Ketones, they have given the general form R C double bond O R dash, can be obtained in one step. They can be obtained in one step by, where R and R dash are alkyl groups. Okay, so they have said that when they have mentioned this point, R and R dash are alkyl groups, it means that they are talking about aliphatic ketones. They are talking about aliphatic ketones. So let us see an example. I want to prepare an aliphatic ketone. That means I'm going to take an example of an aliphatic ketone, a simple ketone. That is our acetone, right? So you want this ketone in a one-step reaction. So what we can do to obtain this in one step? See, very simple reactions we have seen, that is from alcohols. From alcohols. And we have studied this. When you oxidize alcohols, oxidation of alcohols, or let me be very clear, oxidation of primary alcohols gives what? It gives us aldehydes. It gives us aldehydes, right? Whereas oxidation of secondary alcohols, oxidation of secondary alcohols gives us ketones. This is a one-step reaction, right? So if I want a ketone, if I carry out oxidation of secondary alcohol is the OH group attached to secondary carbon. Secondary. When I carry out oxidation using any of the oxidizing agents, chromic anhydride, right? What do I get? CH3, C double bond O, CH3. So the correct option is what? Oxidation of primary alcohols. It should be very clear. Yes. Oxidation of secondary alcohols, because oxidation of primary alcohols gives us aldehydes, and they have asked us ketones, right? So oxidation, and there also, when you carry out oxidation of the alcohols, expected product is final product, the carboxylic acid. I had already shared with you. Yes, you should be knowing the regular, what you can say, the selective reagents. Yeah, if you want to use oxidize, if you want to oxidize alcohols to aldehydes only, then we have to go for a selective reagent, which is nothing but PCC in methylene chloride, pyridinium chlorochromate in methylene chloride. And if you want to go for oxidation of alcohols to aldehydes and then to carboxylic acids, then we are going to use a stronger oxidizing agent like acidified K2Cr2O7 or alkaline KMNO2. Okay, but whereas oxidation of secondary alcohols to ketones only, yeah, if you want to carry out oxidation of secondary alcohols to ketones only, then we are going to go for a selective reagent, that is Zone's reagent, which is nothing but chromic anhydride in water, chromic anhydride or chromic acid in chromic oxide, chromic oxide in acetone or chromic oxide in sulfuric acid. Yeah, so any of these selective reagents can be used. If you are going to use acidified K2Cr2O7, then the secondary alcohols get oxidized to ketones. Ketones, obviously it is difficult for oxidation of ketones, but still the ketones get oxidized to a mixture of carboxylic acids containing the less number of carbon, right? So you should be knowing all these points. Moving to the next question. Which of the starting materials is used for the synthesis of aldehyde by ozonolysis? So ozonolysis of which compound gives us aldehydes? See, if you remember in your first PUC also you have studied something regarding ozonolysis. Ozonolysis, you have just studied what is ozonolysis. But let me make some point very clear to you all students here. Ozonolysis is that a typical reaction, students, where it is also called as you can test the presence of, unsaturation. Unsaturation means what? The presence of carbon-carbon double bond or carbon-carbon triple, where actually these double bonds or triple bonds are present. Yes. So this is a very useful reaction called ozonolysis. Yeah. So it is used to predict the position of, what it is used for, predicting the position of a double bond. So if you want to predict the position of the double bond, which compounds contain double bonds? Obviously it is alkene. It's alkene, right? It is alkene. Predict the position of the double bond. For example, you can see here CH3, CH double bond CH2. Yeah? If I carry out ozonolysis in presence of zinc acid, what do I get? Yes, you have to what happens? The bond breaks here, so CH3, CH2 plus a single bond aldehydes HCH. So looking at the products, you can actually judge where is the double bond. See, you are getting two different products. Yes, the products may be aldehydes, maybe same aldehydes, maybe different aldehydes, maybe an aldehyde or a ketone, maybe same ketones, maybe different ketones. It depends to this. We cannot always say that we always get an aldehyde or we always get a ketone. Okay. So here, very beautiful nature of this reaction is looking at the products. Sometimes you will get a question like, on ozonolysis of a particular compound, we are getting the product so and so. Predict the compound. Yeah. So looking at the compound itself, you can predict what is the reactant. How I tell you, they have given you two compounds which are the products of ozonolysis. What you need to do is you need to join those two carbon atoms. That's it. Which carbon atoms? The carbonyl carbon atoms. So this is the carbonyl carbon. This is the carbonyl carbon. When I join it and put a double bond there, CH3. Finished. This is the starting point. Let us see with a simple example also if you wish. Yeah, I'll tell you. On ozonolysis, I have got a compound. Um, the compound obtained is acetaldehyde and acetate. So predict the reactant, acetaldehyde and acetate. So what we are going to do? We are simply going to write acetaldehyde, CH3, CH4, and I have got the compound acetone, CH3, CH3. And I'm going to find what is the reactant. So when you are finding the reactant, identify the carbonyl carbons. Then between those two carbons, there will be a double bond. So this is carbonyl carbon, and this is carbonyl carbon. So what do I get? CH3, CH, a double bond, C, yes, and this carbon is attached to CH3. It is attached to CH3. This is very beautiful nature of this reaction. So it predicts the position of the double bond. Yeah. Any question, let them two aldehydes, two ketones, an aldehyde and a ketone, two different aldehydes, two different ketones. What you need to remember the trick. Just identify the carbonyl carbons, remove those oxygens, and join them by the you get the compound. Verify, want to verify it? Remove these two double bonds, put a double bond over here, put a double bond over here. Did you get the same compound? Obviously, we got the same compound, right? Okay. So the correct option is ozonolysis. If you want aldehydes, ozonolysis of alkenes has to be done. Moving to the 12th question. Propane can be prepared from ethine. Okay. By. So propane is prepared and the starting compound is ethine. They are saying by this we are going to prepare propane. Always there is always a reaction wherein if you want to prepare saturated compounds, it is from unsaturated compounds, they simply carry out reduction. But here, and when you carry out reduction of unsaturated compounds, you will get saturated compounds corresponding. Yeah, that means the number of carbon atoms in unsaturated compounds, the same number of carbon atoms in saturated compounds. Yeah. Make a slight correction, students. It is not propane, it is propanone. Yeah. So I was wondering where from this first music question came. Propanone it is. Please make this correction. Propanone can be prepared from ethine. Yeah. So you want propanone and you want to prepare ethine. You want to prepare propanone from ethine. Yeah. So how do you prepare propanone from ethine? Yes. So we have studied the method of preparation. When ethine is subjected to hydrolysis 420 degrees Celsius in presence of magnesium, or you can take zinc precipitate. Yeah. So magnesium I take. So I'll take magnesium. You can either go for magnesium, zinc, vanadate. Yeah? Because we have frequently come across magnesium. When you separate it for hydrolysis, what happens is we are going to take here two molecules, hydrolysis 3 molecules of water. What do I get is I get CH3, COCH3 plus carbon dioxide and hydrogen is but this is the method of preparation of heat from. So what is the correct option? The correct option is passing a mixture of ethine and steam over the catalyst magnesium 420 degrees. 420 degrees Celsius. So you should be knowing all the methods of preparations of the compounds, whether it is general methods or it is the typical methods for preparations. Okay, moving to the 13th question. Which of the following will not give aldol condensation? Another interesting reactions. Aldol condensations are shown only by those compounds which have alpha carbon atoms. In the first few questions itself, we have discussed which is alpha position, right? So if you are having an aldehyde or a ketone, so let me say this is carbon atoms, this is carbon. This is the carbonyl carbon. The adjacent carbons become alpha carbons, alpha and alpha prime. The adjacent to alpha carbons become beta carbon atoms, beta, beta prime. Okay. So those aldehydes or ketones which possess alpha carbon atoms, they only can undergo aldol condensation. And we have discussed it many times. Aldol condensation product is beta hydroxyaldehyde or ketone. We're taking aldehyde, we're getting ketone. And we remove water molecules, then we get alpha beta unsaturated compound. So look at the examples. Which example is having alpha hydrogen? So which one is having alpha hydrogen will give aldol condensation? So phenyl acetaldehyde. So CH3 CHO is acetaldehyde. Since you have said phenyl, so having alpha carbons, obviously it is having alpha hydrogen. So this will show aldol condensation. 2-methyl pentanol, 1, 2, 3, 4, 5. CHO, 1, 2, 2-methyl. So CH3. And how many carbons? 1 carbon. Hydrogen, 1 hydrogen. So it is having alpha. See, even if it is having alpha carbon, check out whether it is having alpha hydrogen or not. The hydrogen is there, so it will also show. Benzaldehyde, CHO. There is alpha carbon, but it is not having alpha hydrogen because in benzene ring, when we talk about benzaldehyde, all carbon atoms are having only 1 hydrogen, right? All carbon atoms possess 1 hydrogen, but since here benzaldehyde CHO group is substituted by removing hydrogen, so this carbon is not having, though it is alpha carbon, it is having no alpha hydrogens. It is having no alpha hydrogen. So benzaldehyde will not give aldol condensation. Let us verify with one more last example. 1-phenyl propanone. Propanone is CH3, 1-phenyl. So either here or here, I'll put phenyl group. CH2. So it is having so many two alpha carbons and 3 hydrogens. So this will also show the aldol condensation. So which is not going to show aldol condensation? It is benzaldehyde. Benzaldehyde does not show aldol condensation. Acetaldehyde, moving to the next question. Acetaldehyde, when treated with dilute NaOH, gives acetaldehyde when treated with dilute NaOH. They have said acetaldehyde, it is nothing but ethanol, correct? CHO when treated with dilute NaOH. So it is nothing but aldol condensation. What I'll do is I will take 2 molecules, dilute it, weak is supposed to take OH. So what happens is this plus here, carbon will get a positive charge, this carbon will come here. So what do I get? CH3, this is H, then H, towards CH2, and then CH. Oh, so 1, 2. So this is beta. What is this proposal? 4 carbon atoms, beta hydroxy butanase. there any compound with the same potential? If it is there, we will stop here itself. Of course, it is there. This is the option. If they wouldn't have given this, then there was a further reaction wherein this would lose what molecule, which water molecule, OH and H of alpha position. In that too, alpha position should contain lesser number of hydrogens. So this hydrogen will be gone and then will be a double bond here. So what will we get? CH3CH. Then CH2 alpha beta. It's called 1, 2, 3, 4. But to al, and this is commonly called cinnamaldehyde. Right? It's commonly called as cinnamaldehyde. So look at the option, which option? So we have to do something. So we will be stopping here. But further, if it was not given, then it will be knowing further what is the compound contained also. Yeah. So iodine condensation is shown in those compounds which contain alpha hydrocarbon atoms. Sorry, though there are alpha carbons, sometimes there won't be alpha hydrogens, like the previous question what we have discussed. Yeah, those which contain alpha hydrogens. And then example 15th question. Which one of the following methods, reactions is a method for conversion of ketone into hydrocarbon? You want to convert ketone into hydrocarbon. So ketone into hydrocarbon. So it is nothing but reduction itself, students. Yeah. So reduction. What happens there? We have seen reactions wherein CH3, I'll write it like this: aldehyde or a ketone can be oxidized. Yeah, oxidation reaction to carboxylic acid. Aldehydes and ketones can be reduced to alcohols. If it is an aldehyde, you get primary alcohol. If it is a ketone, you get secondary alcohol. Okay, but here, if you take aldehyde or a ketone, yeah, you can even reduce it to alkane. Yes, and there are two methods. One is Clemenson's reduction. The one is Wolff-Kishner reduction. So which is the option given? It is Wolff-Kishner reduction. Yeah. Example also if you want CH3. So in Wolff-Kishner reduction, we use hydrazine, H2, and sometimes students will be written with this also. Okay, interesting. So we get CH2. CH3. Yes, this is get plus H2. Here we are getting corresponding. Okay. So there's Wolff-Kishner's reduction. Yeah. So the correct option is option Wolff-Kishner's reduction. Moving to the next question. Identify the product Y on the sequence. Yeah. These questions are my favorite questions. Yeah. We'll get so many questions. Everything, entire organic chemistry of first PUC and second PUC gets simplified in such questions. You can identify yourselves whether I'm so perfect in all my organic chemistry reactions just for solving such sequence questions. Okay. So 16th question. They have said CH3CHO is treated with CH3MgI, a very typical compound called Grignard's reagent, which is stable under ether solvent. So what happens here was, I'm sorry, carbon carries negative charge, positive and negative. This should be remembered. This part goes here, this part goes here when you carry out hydrolysis. Okay, let us see first part. What is we are getting CH3. There is carbon hydrogen. To this carbon, what is moving? It is here. Sorry, it is not but it is to this carbon. positively charged. So this is positively charged, it acts as a file. Lipidic center, so CH3. Here single bond, oxygen is a negative charge, Mgr. So this is our X. Yeah, this is our X. Now they have asked the sequence. The next one they have subjected for hydrolysis, acid hydrolysis. Okay, what happens? CH, CH3 plus X. Secondly, CH3, CH, option. Right. Here, students, I give you one more hint. Remember, yeah, if you take formaldehyde, treated with Grignard's reagent, you are always subjected for hydrolysis. You are always going to get hydrolysis. Okay. If you take any aldehyde except formaldehyde, you are going to take formaldehyde, but you are going to take any aldehyde and do it with a Grignard's reagent. Always end up with second one, just as this one is now. And if you take any key, no question, any key, treat it with Grignard's reagent, subject for hydrolysis, you will always remember this. Always. Okay. Always you take any if you take formaldehyde and treat with any Grignard reagent, you're going to end up with primary alcohol. Always. Any aldehyde except formaldehyde with Grignard's reagent gives you secondary alcohol. And any ketone with Grignard's reagent will give you tertiary alcohol. Is that clear? Okay, so which is the correct option here? The correct option is option C. Fine. Okay. So moving to the next question. Which of the aldehyde is most reactive? They have given benzaldehyde, they have given acetaldehyde, they have given formaldehyde, and they have said all are equally reactive. See, students, among carbonyl compounds, reactivity decreases with increase in alkyl group because alkyl group is shows positive inductive effect. So reactivity goes on reducing as alkyl groups increase. Yes. So that decreases the positive because it decreases the positive character on carbon atom. Okay. So which is the correct order? The correct order, you just find the correct order that will give you the answer for your question. So correct order comes out to be what? Just look at the all questions, you will understand. So if you see HCH2 reactive because there is hydrogen which doesn't contribute to anything. Then we have CH3, CH2, and we have asked which one of the following is 18th question. Which one of the following gives aldol condensation? So which is aldol condensation? Which is having alpha carbon attached alpha hydrogen. Here no question. You see here it is having alpha carbons but no alpha hydrogens. Look at this option. There are 3 alpha hydrogens this side, there are 2 alpha hydrogens this side. Here there is no alpha hydrogen, but here there are alpha hydrogens. So, although both option C and D are having alpha hydrogens, yet CH3 tries C, then C double bond of CH does not undergo alpha hydrogen because here, if you write the structure, there are 3 methyl groups attached to carbons. So this becomes a very material group. To undergo aldol condensation, electrically mixed carbon atoms. So what happens basically due to steric influence of the bulky crystal of this bulky. So the nucleophile will not attack very easily. Yeah? Therefore, this doesn't show aldol condensation. So the correct option is option C. So it will show. Understood. So even if there are alpha hydrogens, look at which of the following is there is sterically hindered carbon. If there is sterically hindered carbon, then it will not show aldol condensation. 19th question. If formaldehyde and KOH are heated, so you are taking formaldehyde, which doesn't have alpha. Formaldehyde is not having any alpha hydrogen, and you are going to treat it with KOH. Formaldehyde plus KOH. What are molecules? Right? This is a very important reaction. So this is reaction known as two molecules of aldehyde, formaldehyde. It is nothing but Ketones reaction. I think it's ketones do not have alpha hydrogen. We have to go to this proportionation. This one molecule gets oxidized. So formaldehyde gets oxidized to what we can say. This present. Twentieth question. Benzaldehyde on reaction with acetophenone in presence of sodium hydroxide solution. See, this is having alpha hydrogen. Not having alpha hydrogen, so it's a Ketones it is working reaction. So this hydrogen comes with this. So what I'm saying is this will go to H C. So very important, where they have stopped the reaction, you should be first analyze it. Okay. Moving to the next question. Which of the following compounds will undergo self-aldol condensation in presence of cold dilute alcohol? See students, since which one is having alpha hydrogen, that will undergo aldol condensation. So since CH3, CH2, CHO has alpha hydrogen atom, it will undergo aldol condensation in presence of cold dilute alcohol. So option B is correct. Okay. Rest all are having double bond, so there will be difficulty in undergoing aldol condensation. 22nd question. Arrange the following compounds in the increasing order of their reactivity in nucleophilic addition reactions. For nucleophilic addition reactions, remember ketones are less reactive than aldehydes. Ketones are less reactive than aldehydes. So as the number of carbon atoms increase, the reactivity also decreases because nucleophile has to add, right? Nucleophile is a negatively charged, right? So which is least reactive? The correct option is option A. Aldehydes are most reactive, so quite obvious, ethanol comes last. So which option contains ethanol? It is only option A. Or you can also think like this. More the number of carbon atoms, less the reactivity. So butanone, then comes propanone, then comes propanol, and then comes ethanol. Okay. So option A is the correct option. Moving to the next question. The methanol, ethanol, and propanone are miscible with water because they form. See students, lower members of aldehydes and ketones, they are miscible in water because of the capability of forming hydrogen bonds with water. Yes, they do form hydrogen bonds with water. Therefore, they remain soluble in water. Yes, that is the reason lower members only. I'm speaking about the lower members only, right? So the correct option is due to the capability of forming hydrogen bonds. 24th question. Identify the example in which nucleophilic addition and nucleophilic addition elimination reaction both occur respectively in the carbonyl compounds. So important examples of nucleophilic addition reactions we have seen in carbonyl compounds. Addition of hydrogen cyanide we have seen. Addition of sodium hydrogen sulfide we have seen, NaHSO3. Addition of Grignard's reagents we have seen. And important reactions where nucleophilic addition come elimination occurs. That means when the two compounds are getting added and there is addition reaction, there is elimination of small molecules like addition of ammonia and its derivatives, right? So the correct option is what? It is option D. Reaction with alcohols. So both reactions occur. Reaction with alcohols. Okay, so you should be knowing all the reactions of aldehydes and ketones. 25th question. Condensation product of benzaldehyde and acetone. Condensation is a reaction where addition and elimination both occur. Addition of the compounds if they enter molecular. They have said condensation of benzaldehyde and acetone. Okay. And acetone. This what we take. And write water, that is water reaction. This no, it's not option B, it is option D. Right? D is the right option. 26th question. Which of the following is most reactive to the nucleophilic addition? See, there are halogen atoms attached to the carbons. So which one most reactivity depends on the halogen atom. So which is most reactive? Chlorine. This we have discussed. And as the number of electrons releasing increase, the activity increases. So here there is no that question. Here the question is on this. So which is most reactive? It is option A, which is most reactive. Then chloro substituted product bromo substituted. 27th question. Which of the following compounds will undergo Kenzal's reaction? Which is not having alpha hydrogen that will undergo Kenzal's reaction. So it is option C, benzaldehyde. Rest all are having alpha hydrogen. 28th question. There is a large difference in the boiling points of butanol and 1-butanol due to, see, butane 1-ol has higher boiling point than butanol. It is because in butane 1-ol there is intermolecular hydrogen bond. Yes, there is intermolecular hydrogen bond. So therefore, option A is correct. Butane 1-ol has higher boiling point due to intermolecular hydrogen bond. Butanol is a higher member of aldehydes and they do not form hydrogen bonds. Only the lower members like methanol, ethanol, propanol will form hydrogen bonds. Okay. 29th question. Arrange the following compounds in the increasing order of their boiling points. Yes. So I discussed just now. Alcohols form the hydrogen bonds with water. Aldehydes, the higher aldehydes do not form. Third, we have esters. They do form ethers, but less than alcohols. And fourth, if you see, it is an alkane, highly hydrophobic towards water, does not form hydrogen. So higher order, where there is strong hydrogen bonding, that will be requiring more temperature. So they are in decreasing order, right? So option 4 is having lower boiling point. Then comes option 3. Then comes option 1. And last is option 2. So it is 4th. So C option which is correct, right? C option is correct. 30th question. Which of the following statements is or are correct about aldol reaction? Aldehydes and ketones having at least one beta hydrogen, which is correct, they have said. Okay. No, it is wrong because aldehydes and ketones having at least one alpha hydrogen will show this reaction. The reaction is carried out in presence of concentrated, obviously not. The reaction is carried out in presence of a weak base. So usually we take a weak base or sometimes we take a dilute alkalis, right? The product formed is beta hydroxyaldehyde aldol or beta hydroxy ketone. Obviously, yes, the product formed is beta hydroxyaldehyde or beta hydroxy ketone. So the correct statement is option C, which is the correct statement. 31. Aldehydes that do not undergo, the question has repeated, the aldehydes that do not undergo aldol condensation are propanol. Look at the options. The option which is having alpha hydrogen will not undergo, the option which is having alpha hydrogen will undergo aldol condensation, and the option which is not having alpha hydrogen will not propanol. CH3, CH4. Yes, it has. Trichloroethanol. Ethanol, trichlor. So CH3, not having alpha hydrogen, not 2-phenyl ethanol. This ethanol, 2-phenyl. Here it is. Yes, it's having alpha hydrogen. So which do not undergo, it is option 2. It is option 2. Not 2. So it will not undergo aldol condensation. Right? C2H5CHO and CH3. This is C2H5CHO, propanol. So these two can be distinguished by. They can be distinguished by distinguishing hydrazine, hydroxylamine. If you see, these two are the reactions which are condensation reactions, addition as well as dissociation. Sodium bisulfite is just an nucleophilic addition reaction. Telling solution is oxidation reaction. So should be knowing all of them. 32nd question. Oxidation reaction is shown by only aldehydes. It is not shown by ketones. Whereas Nucleophilic addition, nucleophilic addition elimination reactions are shown by all the aldehydes and ketones, with certain exceptions where there comes the steric endings, which is the correct option. C. So, how do you justify this question? If you take propanol, propanol reacts with Phenyl solution to give a red precipitate, whereas propanone does not react with the Phenyl solution to give the red precipitate, because they are, ketones are susceptible. They are susceptible for oxidation, so they do not react with mild oxidizing agents. Okay. 33rd question. Dimethyl ketones are usually characterized through which reaction? They are usually characterized through iodoform test. Those methyl ketones show iodoform test. Silver mirror is a test for aldehydes. Yes, it is test for aldehydes. Acetaldehyde and acetone. Same question. CH3CHO and CH3COCH3. These two can be distinguished by. They can be distinguished by tolerance test, right? Because all of the reactions are shown by, say, similarly, both of them react, whether it's Molish test, bromoform test, that is iodoform test, or solubility in water. Because acetaldehyde and acetone are lower members, they get dissolved in water due to formation of intermolecular hydrogen bonding. Molish test is shown by both of them. But tolerance test, oxidation test, is not shown by ketones. Acetaldehyde will give silver mirror with tolerance reagent, ammonia for silver nitrate solution, whereas acetone does not give the silver mirror with tolerance reagent. Next question. Acetaldehyde cannot show which of the test. Acetaldehyde CH3CHO does not show which of the tests. It will show tolerance test, obviously. It will show iodoform test. Yes, it is having methyl ketone. It will show Benedict's test, that is NaHSO3. Yes, it will show. But what about Lucas reagent? Concentrated HCl, zinc chloride, concentrated HCl. It will not show anhydrous AlCl. It will not show Lucas test. Alcohols give this test. Aldehydes do not show this test. Lucas test is for primary, secondary, and tertiary alcohols. Next question. Select the reagent used in haloform reaction. It is sodium hypohalite. Option C is correct. That too, we do not use it directly. It is sodium hydroxide with iodine, which gives sodium hypohalite, NaOI. That is treated with methyl ketones or methyl aldehydes to give haloform reaction, which we also call it as iodoform reaction. Choose the correct statement. Acetaldehyde is used as a starting material for the manufacture of acetic acid. No. Benzaldehyde, yes or no? Acetaldehyde, a 2-carbon aldehyde, is used for starting material in manufacture. Yes, it is true. Acetaldehyde, acetic acid. We get acetic acid. So only the name is derived as acetaldehyde. Aldehydes' common names are derived from carboxylic acid common names. Acetic acid, acetaldehyde. So that statement is true. Benzaldehyde is used in perfumery and in dye industries. Yes, that is also correct. Yes, so acetaldehyde is used primarily as a starting material in manufacture of acetic acid, methyl acetate, vinyl acetate, polymers, and drugs. Benzaldehyde is used in perfumery and in dye industries. The correct option is option C, both A and B. 39th question. Formalin contains what? Formalin is an aqueous solution of what? See students, formalin is an aqueous solution of formaldehyde and methanol. You can note it down. That too, the concentration, the ratio should be knowing. 40% of formaldehyde, 8% of, yes, so you should be knowing the ratio, how much of the compound is being used. So formalin, if you see, formalin contains 40% of formaldehyde plus 8% of methanol and water. So this is the ratio 1:1. This is the ratio of 1:1. The scores, right? 40% of formaldehyde, 8% of ethanol, and 52% of water. It is used as, you can mention, it is used as biological preservative. Plants. So it is a solution of water and in water, aqueous solution. Choose the incorrect state. So this is the correct option. Choose the incorrect statement. 40th question. Acetone and ethyl methyl ketones are common industrial solvents. Yes, acetone. Ethyl methyl ketones. These are industrial solvents, obviously. Butaldehyde, vanillin, acetophenol, camphor, etc. are well known for their odors and flavors. Obviously, yes, that is also good. Yes, they are known for vanillin, camphor, butaldehyde. They are all good, very well known for odors and their flavors. So both A and B are correct. So this is the incorrect statement. None of these. So this is the incorrect statement. Yeah. So both options are correct. So it is this, right? Okay. So we will stop with these few questions. In the next class, in the next video, I'll be posting up with the next few questions. I will be discussing with next few questions on aldehydes, ketones, and carboxylic acids. Hope you are enjoyed the class, cleared with it.